Recording. Great. Okay. Okay. Can you hear me well? I'll make my voice high enough. Now, we have this sheet, which covers everything in the material. And I uploaded also the review for chapter 8 and chapter 10, chapter 9. These are they. You can see them. Going. The final exam is in the same day. It will be in 9th of December, Wednesday. At the time of the lecture, I think it will be, I will tell you about that. But the exam, I think it is at but I will tell you about this point. I can't see it now on the syllabus. Can you hear me well? Great, thank you for that. Now, I will share now this file. Astaghfirullah. Yes, okay. Where start sharing? Okay, share. Can you see my view now?
Yes.
Thank you for that. Okay, now this is the material for the final exam. It will be from chapter 8, 9, 10, 11, and 14. From chapter 11 and 14, we have selected topics, not all the material. Chapter 8 will talk about momentum and impulse, conservation of linear momentum, and we have their relations also. Also, we talk about an example of rocket propulsion. In chapter 9, we talk about the angular motion. We need to know about theta, omega, and alpha, and the motion, angular motion with constant angular acceleration, which is the same as the linear. And there is relations between the angular quantities and linear quantities. We apply that. Also, we have the energy, which is the kinetic energy mainly, and we apply moment of inertia to solve the energy. In chapter 10, we talk about torque and the angular acceleration. It is, and also again, the kinetic energy, work, and power in angular motion. It is the same as the previous material, but in angular motion. We have also talk about angular momentum and conservation of angular momentum with a simple example. Also in chapter 11, we have 3 sections, simply constant motion and equilibrium. Yes, equilibrium, which is Newton's first law, but equilibrium in general, and we need the total forces and total torques are equal to 0. We need to find what is the center of gravity, which is the same as center of mass in the case when G is constant. And we need to solve any problem using the equilibrium conditions. And we did that, and you'll see that in the quiz, I think. Finally, we need to talk about the periodic motion and simple harmonic motion, and using 2 examples, which are the spring and the pendulum. We have a relations in time, which is the position and the velocity and the acceleration in time, which is A cosine omega t, and omega simply is given. And we need to know the energy, which is the mechanical energy, the usual formula what we learned from before. This is all the material, okay? If you have any issue, any question about any of these material parts, please tell me. Also, about this is the first sheet. We have the 5 chapters, we talked about them. Before the course evaluation, also I need to talk about the final exam. You can use, it is an open book. It is open book exam. You can use any material you want. Also, you can prepare your formula sheet and put it in your table when you start your exam. But don't make yourself confused by many things. Don't use the 2-3 books. At the end, you need to know how to solve the question. You don't need just to look at the book. The solution is not in the book. It is not in the formula sheet. It is put here in your mind. Because of that, you can use any formula. If you need to ask me, if you prepared any formula sheet and you need to use it, and you need to ask me if it is suitable or not, just send it to me. I will tell you. I will prepare it for you. In general, it is an open book exam. You will see maybe from 20 to 25 or 30 questions. That's all about the final exam. Anything new, I will tell you about email, by email. Please be in contact with your mail box. The course evaluation. Now we have 52 students. I have 30 evaluations, just 30. So I need more feedback. This is important to me. This is important to the department. And you have extra, you will earn extra credits for those who didn't do it yet. It will take 3-4 minutes, I don't know. Today we'll talk about chapter 8 and chapter 9. The material is uploaded in Canvas. These are many examples, and they are uploaded, and they will be also the same for the last chapters. And I will show today some of these examples and discuss them with you. So if you have any other, question, you need to discuss it or solve it, please send it to me and I will solve it for you, and I will record that. Now, I will start with chapter 8, which is momentum. Which is momentum and impulse. For example, the first example, any questions so far? There's chat, can we listen? Yes, you can. If you like, I will put your music now in the lecture if you, because I like music. And the exam will be using the lockdown browser. But if you have any issue, please tell me during the exam. My phone number is with you. You can contact me by messaging. Okay, now if we have, I'm talking about the first example. I need to start. Any question before that? I need to talk here. Okay, the first example, which is exercise 8.1. What is if we have a mass equal to 12,000, 12,000 kilograms, and its velocity is equal to 13 meters per second. We need simply to find the momentum. We don't have any information if this motion is in X or in Y direction. So we will take it just in one dimension. We don't know where is it. If it is in X or in Y, it is just in one dimension. So we can solve it simply as a magnitude. It is mv, which is equal to 12,000 multiplied by 13. This will give us the answer, which is given here. By the way, these examples are put in on Mastering Physics. So you can go there and solve them by yourself. And with the same number, it will be 1.6 e 10 to 5, or multiplied by 10 to 5 kilograms meter per second. Now, if we have another object, if we have, this is mass 1. If we have M2 with another mass, which is kilogram, but with the same speed, which is this one, how much the velocity? How much the velocity? What is the chat now? Okay. Okay, now we need to find the velocity. This is the first object. This is another object. This mass is at 12,000, but this one is smaller. If we give it the same momentum, then do you expect that the velocity will be more or less if we give it this momentum for a big mass? For a small mass, this velocity will be larger because small mass. Assume that we have a big ball and a small ball, which is a big ball. A big ball. This, if this hit this one, this velocity will be high. Now we can find the velocity. V2 is equal to P, which is the same that one, over the mass, which is 2,000. This will give us almost 71 meters per second, approximately. So its velocity much higher than this one because the difference of mass. Okay, what we have also. What about the kinetic energy? Yes. Now, we have this system with this big mass and this system with this small mass. If we take the momentum for the first mass and give it to the second mass. Now, this mass, big mass, this is the smaller mass. We give it the momentum. Then its velocity is equal to 71 meters per second. What if we give it the kinetic energy? We need to compute that. How much the kinetic energy initially? Kinetic energy initially for the first mass is equal to m1 over 2 v1 squared. Okay, this will be equal to, you need to compute it, okay? I think it will be, where's the calculator? Ah, it's here. It is half multiplied by the mass, which is 12,000, multiplied by 13 squared. It is equal to 1 million joule. What if we need to find the velocity for the second object? Now we give this object this energy. Okay, so the kinetic energy for the second object is the same like this one, which is 1 over 2 mass 2 multiplied by V2 squared. Now this V is different than that one. Okay. Now V2 squared is equal to 2 kinetic energy, which is this one, over the mass. We need to remove the square sign with the square root. This will be equal to multiplied by 2 divided over the mass. It will be approximately 30 meters per second, as you see in your sheets. Yes, right. This is okay. This is for the first example. The second one, I will solve part of it. If we have the system of particles, A, B, and C. C has a velocity to this direction. A has a velocity to this direction. B has a velocity to this direction. MA is equal to 5 kilograms. MB is equal to 6 kilograms. MC is equal to 10 kilograms. The velocity of A, it is to the negative y direction. You can see that. V is equal to 11.4 meters per second, negative J. PB is equal to 9.6 meters per second in this angle direction, which is 60. Theta equal to 60. We can decompose it to Bx and By. What about C? VC is equal to 3.2 meters per second to the negative I hat. Simply, we need to find the momentum for this system, for the first and the second object and the third object and so on. Okay, for the first object, PA is equal to MA multiplied by the velocity for A, which is equal to, the mass is 5, the velocity is 11.4. It is in negative J hat. Plus 0 I hat. We don't have any momentum component in Y direction, in I direction, yes. This will be equal to 2.57 with negative sign J hat. That's it. What about PA? PB, I'm sorry. This is as a vector. These chalks are okay, PB, which is equal to B has X and Y component. It is the mass, which is MB VB I hat in X direction plus MB VB in Y direction, J hat. But Vx and Vy, we can't find them. The mass is 6. V, it is the velocity, which is 9.6. Cosine 60. Cosine is in the direction of the angle. Okay. If you have any issue about that, please tell me. Is PA in the negative? Yes. Yes, it is in the negative Y direction. PA. Now, this is an I hat plus the mass multiplied by the velocity, which is the speed, multiplied by sine 60. J hat. This will be equal. This is PB as a vector. This will be equal altogether using the calculator. 6 ضرب 9.6 cosine 60, which is half. It will be 28.8. You can see now. I hat plus all of B's momentum in positive direction plus. We need to apply sign now. Plus 49.9 J hat. Now we found PB. What about P for C? For C, we don't have any Y direction. We just have negative X direction. 50 joule, what do we, 50 J hat, yes. It is almost 50. It is mass for C multiplied by velocity for C, which is just in I direction, plus the mass for C multiplied by zero velocity in j direction. This will be equal to the mass is 10, the velocity is 3.2 with negative sign. So it will be negative 23 I hat. This is the momentum for P. C. For the particle C. Okay. If the question asks us about anything, now we know it. Now we have three momentums. P A is equal to 0 I hat minus 57 J hat. P B is equal to 28.8 I hat plus 49.9 J hat. And we have PC is equal to negative 32 I hat plus 0 J hat. And all of them have 0 K hat, 0 K hat in Z direction. The questions in that example ask you about a system for two particles, for these two particles, for these two particles. You need just to add them together to find the total momentum each time. So if you need a system for this and this, you need to add that two momentum in Y direction and in X direction, and the same for this. I will pass. Now we did everything. Okay. I need to save time. A, we need for PA and PC. What is the X component? We need to add them together. For B, we need to, for E and C, BA and C in Y component. C, B and C, we need the X component and the Y component, and then for all of them. We can do it. Any question about that? I'll go to the next. The next example, just to find the momentum, exercise 8.5. Also, to find the momentum, I will move to a collision example. Yes. Now I'll go to sheet number, I don't know the number. Because we have another sheet, another chapter for today. Now, for example, we have collision. If we have a puck with mass M1, let us say MA is equal to 0.251. Why is this one? Kilogram. And another MB is equal to 0.371 kilogram, which is initially at first. B initially is 0. And VA initially is equal to 121 meter per second to the left in negative I direction to the left. VA initially. No. We don't know. Initially, we don't know the velocity for the first object. After the collision, this is A, and this is B. VA after, finally, to the left is 0.121 meter per second, and VB, finally, to the right is equal to 0.651 meter per second to the right. Now, what is the initial velocity? Yes, what is the initial velocity? I will remind you by two equations. If you remember, for the elastic collision we have, in the condition when the second object is at rest, we have VA after, I'm talking here after. VA is equal to MA minus MB over MA plus MB multiplied by VA initially, and VB is equal to 2MA over MA plus MB multiplied by VA initially. We need to find this one. We have all of these are given. We need to find VA and VA. This is after. Now, we need just to apply it. VA after, it is 0.121 is equal to the mass, the difference between the masses. It is 251 minus 0.371 over the summation of them, 0.251 plus 0.371 multiplied by VA initially. By that, you can find VA .841 meter per second. And I don't know about this one, but it is existing that in the example. You can find it by two ways. Okay, what else? Calculate the change in kinetic energy. Okay, the kinetic energy initially is equal to the kinetic energy for A plus the kinetic energy for B, which is equal to half MA VA squared initially plus half MB VB initially squared. But VB initially is 0. Then there is no contribution from the object B for this kinetic energy for the system in this system. Okay. Now the kinetic energy initially is 1/2 the mass multiplied by VA squared. This is the mass for A. So this kinetic energy, I'm sorry for this board, it is small. So kinetic energy initially is equal to 1/2 The mass for A, it is, how much is it? Again, zero point 251. The velocity, which is that one, 0.84 squared. This is the initial kinetic energy. It will be equal to some number. This half multiplied by 0.21 multiplied by the velocity squared, which is 0.841 squared. It is 0.0887 joules. Now, this collagen is this is the kinetic energy initially, which is the same. If we move this decimal point, it will be 8.87 multiplied by 10 to minus 2 joules. Now, again, you can find the kinetic energy finally, which is equal to kinetic energy for A plus the kinetic energy for B after the collagen, which is equal 1/2 MA BA squared after plus 1/2 MB VB squared after the collagen. You will have another number. Now, the change in kinetic energy, it is not fully elastic collagen. Now, the change in kinetic energy will be kinetic energy finally minus kinetic energy. Change in kinetic energy for which part here? Calculate the kinetic change in kinetic energy system. Initially, this will give you a small magnitude, which is negative. There is a lost kinetic energy, 8.36 multiplied by 10 to minus 3 joules. The change in energy is negative, so we have lost kinetic energy. And this example or this system is not fully elastic. Okay, what is the next one? How much time now? Okay, we can solve just one example about the momentum. I need to give more time for rotational motion, because in general we are good in linear motion problems. Okay, now we have to push each other, two persons on IC skiing yard. Now they push each other to this one to this direction and this one to this direction. One of them its weight M1 is equal to its weight over G. We need to know the mass, and the question gives us the weight. The weight is equal to 755 newtons over G. This is the mass for the first one. The second one has a mass is equal to his weight, which is 655 over G. We need the mass, we don't need the weight, okay? Now, initially, their momentum, P initially is equal to 0. Then P finally, after they go away from each other, finally should equal to 0 also. Okay, we have a mass and velocity for the first one, and we have a mass and velocity for the second one, which is the momentum, and their momentum should be equal because one of their momentum, P1, is equal to positive in x direction, and the second momentum is negative to the negative x direction. Now, P1, P initially equal to P1 plus P2. Because their velocity is equal to 0, then the momentum is 0. Now here we need to apply that equation. P1 is equal, or P initially, is equal to 0 and is equal to P finally, which is equal to the first momentum, P1, plus the second momentum. So 0 is equal to P1 is M1, V1. M1, we don't have the mass, we have the weight, which is 755 over G. This is the mass, because the weight is the mass multiplied by G, multiplied by velocity. V1, is it given or not? Yes, the heavier mass, which is 755, it is more than 655. Its velocity, his velocity is 1.5 plus the second one, mass is 655 over G multiplied by the velocity. We don't know how much the velocity now. We need to find it. We'll move now one term to another side, then it will be with negative sign. It is negative 655 over D multiplied by D2 is equal to 755 over G multiplied by 1.5. Now we can cancel G from both sides. So you can see the solution in this way. Simply divide over this argument. D2 is equal to 755 over negative 655 multiplied by 1.5. It will be equal to 1073 to the negative x direction. We need to give it a negative sign. We don't have negative sign here, but it is mentioned. I think it will be mentioned that to the negative x direction, meter per second. Now, how much the kinetic energy created? Now, this is just like a collision, but going back in time. If we reverse the time, then we have a motion to the initial point, which is this one. And then they will stick. This is a full inelastic collision in this way. We have two things. We have full elastic collision. We have many masses. We'll combine just one mass. This is full inelastic collision. But what if we reverse the arrows? We have this experiment. This is an explosion, just like the fireworks explosions. It is the same as inelastic collision. We have one object divided to many objects, and we can apply the collagen relations on explosion. Now this is just like an explosion. The kinetic energy initially is equal to 0 because the velocities are 0 for both of them. What about the kinetic energy later? Kinetic energy finally is equal to first one, kinetic energy plus second one, kinetic energy. This will be equal to 1/2 m v1 squared plus 1/2 m2 v2 squared. We have the masses. Half is a constant. The velocities, we have them. We have 1.5, 1.73 with negative sign, but the negative sign will be positive after squaring. Then the total kinetic energy finally this is V2. We use it here. The mass is given. The mass is given. V1. This is V1. The kinetic energy will be equal to 187 joules. What is the change in kinetic energy? The change in kinetic energy, it is K2 minus K1. K1 is 0. K2 is this. This minus 0, it is the same as the second kinetic energy. Is that clear? You can't shake your camera or you can say anything. Okay. Now, what else? That's enough for momentum. And you can see many examples are solved and with hints, with the discussion. And you can, I have trust in you, you can do it. And please, anytime, if you have any question, just send it to me and I will solve it. And I am sorry, I didn't have any time to solve and record any thing in the vacation. I didn't finish even my duties. Okay, what is the next? Rotational motion, yes. Now we need to talk about the rotational motion. We have rotational motion. We have a circle and its radius is r, small r or capital R, it's okay. If we move our object on the surface of that surface, the edge of that circle, this sector, we call it S. It is a section. This angle is theta or delta theta, or from theta 0 to theta 1. This is theta 0. This is delta theta, or theta 1, you can name it. If we move again to this theta, this is theta 2. And we have delta theta 2 from here to here, and so on. And we have this, for example, theta 3 from here to here. This is the third point. Now, the relation between angular motion and linear motion, this one. We have S is a linear distance, but theta is angular distance. So S is equal to R theta, or delta S is equal to R delta theta. This is angular. This is linear. Sorry about this R. Okay. Now, if we have S1 and S2, we know that the velocity is equal to S2 minus S1 over delta T. Right? Now, S1, S2 is R theta 1, R theta 2. And delta T is the same. Now, we can do this. Omega is equal to theta 2 minus theta 1 over delta T. This is, I'll show you. So this will be equal to delta S over delta t. This is equal to the velocity. Now S is equal to r theta. R is constant. There is no change in R. So this is R outside the delta. Delta theta over delta t. It is omega. So V is equal to R omega. So V is equal to R omega. The angular velocity, the rate of change of theta. By the same way, this is V, yes. If we have this is V, tangential. If we have any tangential acceleration, we can compute it by this. A tangential is equal to R by alpha, multiplied by alpha. Alpha is the angular acceleration. Alpha is delta omega over delta t. It is the same as the acceleration is equal to delta v over delta t in linear motion. Also, we have A radial. The centripetal acceleration, we apply it many times. A R is equal to V squared over R. We apply it in the earth motion or any other motion, in the circular motion. But V is equal to R omega. Square the square because it is squared over R. Now we can cancel R with the square. Then we have, it is R omega squared. Then the acceleration radially. This is AR. The acceleration to the center of rotation. It is equal also R omega squared. It is another relation for it. Okay. Now we need to apply some examples. For example, you need to be careful about the angles in degrees and radians. The first example in radians. If we have what angle radian? It's certain by arc. We have an arc, cos. It is S equal to, this is section of the circle. S equal to 1.5 meter. This one, maybe it is just a typo or something like that, because it exists everywhere. The regular circumference of the circle radius, the radius is equal to 2.5 meter. What is the angle in radians? Needs theta. We need theta. R is given, S is given. Theta is S over R. In radians, it will be 0.6 radian. This is theta. Okay. Part B. Now this is geometry. It is math, not physics. What is the angle in degrees? We need to convert theta from radians to degrees. Okay, in radians we have 0.6. Each pi is equal to 180 degrees. This is a radian. This is radian system. This is radian system. This is degree system. Okay. So how much theta in degrees? We need just to cross product like this. Pi x is equal to 0.6 multiplied by 180. We have a 0. So x is equal to 0.6, 180 over 5. This will give us Mm. Hi, Mohammed. Hello. Hi. I am in the office. There is a class now. Yeah. Yeah. Give in a glass. I'm sorry, I can't talk with you now. But sorry about this. Okay, now it will be in degrees, yes. It will be 34.5 degrees. Just you need to do it. Pi, when you use pi in calculations, you can use it 3.14 simply. Okay. What else? If we go to exercise 9.4, if we have omega as a function of time equal to gamma minus beta t squared. Gamma and beta, it's just constant. You can name it A and B or anything like that. Now, calculate the angular acceleration. We know from before that, remember that x of t is a function of time. V of t is dx by dt. We know that, and we apply that for the angular motion. And the acceleration as a function of time is dv by dt, which is the second time derivative for the position function. The same we have for the angular motion. We need to find alpha of t. It is the time derivative of that. Alpha, beta, and gamma are constant. Then we need to derive this. It will be 0 minus 2 beta multiplied by t. That's it. Okay. If now gamma and beta are given, gamma is equal to 5 radian per second, and beta is equal to 8, 0.8, I think radian per square second or second cube. Okay. And the time is equal to 3.1. I don't need 1 second. We can find now the acceleration. We can find omega. For example, omega of 3. It is gamma minus beta and 3 squared. Gamma is given, which is 5, minus beta is 0.8. Yes, it is. Yes. 0.8 multiplied by 3 squared. This is omega of 3. Alpha of 3 is equal to this relation. What is the relation? This one is equal to -2. Beta is 0.8 multiplied by t, which is a 3. Okay, now you see now here omega z and alpha z. We learned from before that the rotation. This rotation in z direction means if we have this is x and this is y and this is z, and if the rotation in xy direction, the object is rotated here, then its rotation using the right hand rule, then it's direction to z direction. So omega in z and alpha in z. You can see z because of that. We talk about that in the lecture. For the same alpha and beta, calculate the average acceleration. Now we have acceleration at the time equal to 0 and acceleration at time, I'm talking about part C, at time equal to 3. How much the acceleration at t equal to 0? If we put 0 here, then the acceleration will be 0. Acceleration at 0 is equal to 0. Acceleration at 3, it is 3.1, it is negative 4.8. This is almost 4.9, it is negative 5 approximately, okay, as given here. Now, what is the average? The average, you can add them together, then divide over 2. Then it will be negative 2.5 radian per squared second. You need to find the acceleration at each point. This is the average value. Now, we have 15 minutes. The next question is the same. We have a function in time. Okay. The next question is the rotating spinning a grinding wheel. Okay, what is it? At time, we have angular velocity. So omega naught at t equal to 0. We have the givens now. I'll put the givens. It is just like v naught or v0. Omega 0 is equal to 26 radian per second. Okay. Constant angular acceleration alpha is constant. The acceleration is 31 radian per squared second. Now, what else? Until we have time or delta t is equal to 2.1 second. Okay. From then, yeah. We have delta theta is equal to 436 radian. What we need to find? A. How throw it to the angle that the okay. Now we have the equations V2 is equal to V1 plus AT. V2 squared is equal to V1 squared plus 2AX. X is equal to X node plus V naught T plus half A T squared. Now, this is in linear motion. We need to do it in angular motion, okay? The velocity is omega. The velocity is omega. The velocity is omega. So this is omega 2 is equal to omega 1. Omega, omega. And this is also omega 1, omega 0. The acceleration is alpha. Okay, this is alpha. This is alpha. This is alpha. It's the same equation. The time is the time. The position is theta. So x will be theta. This is theta. 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 Can you see? Yes, you can. Okay. Now we need to find, I think this is the solution. We need to find theta. If we have, this is the initial velocity, this is the acceleration, and this is the time interval. We need to find theta after this time. Okay? We need to apply one of these equations. They are the same as the linear equation. Which one we will use? Omega naught is 0. So this is omega initially. So we will use omega 1 is 0 and this omega 1 is 0. We need to find theta. We need to use even the second or the third. Omega naught is 0 also. We can assume, because he asked us about the change in rotation, the number, yes, the change in angular position. We need theta minus theta naught or delta theta. In general, we need delta theta. If you move this one to this side, it will be negative. So we have delta theta is equal to this magnitude. We need to find delta theta. We have alpha. لا omega naught not 0. I'm sorry. It is not 0. You're right. If you told me it is not 0, yes, it is not 0. We can apply it. Now, we can use the third one. Delta theta is equal to omega naught, which is 26, multiplied by the time, which is 31, plus the acceleration, which is given 31, multiplied by the time squared, which is the time is 2.1. 2.1 squared. I'm sorry for that, but I'm trying to solve more for you. This will give us I think this is the answer. It will be yes. .559 radians. Okay. Now for part B. What's the angle when the wheel being slowed down? What's the angle? Uh, I'm sorry, just give me some time. I I don't recognize what is the this requirement, but I will check it and I will tell you about it. I'm sorry about that. Let me move to another question. We don't need to lose more time. We have 3 minutes. Exercise 9.9. If angular acceleration is constant equal to, if we have a bicycle and its initial angular velocity omega 0 is equal to omega radian per second, and the acceleration is constant as alpha is equal to 0.2 radian per square second. What is the velocity at time after delta t is equal to 2.5 seconds? What's the angular velocity? We need to apply the first equation. Omega 2 is in the time. It is equal to omega 1, which is omega. It is not 0, plus the time multiplied by alpha. Alpha is 0.2 multiplied by the time, which is 2.5. This is the, it is omega 0, for example. It is omega 0 plus 0.5 radian per second. If omega 0 is 0, then this is our answer. If omega 0, any other number, we need to add it to this. For the previous question, I will do it and I will record it for you. Don't care about it. Okay, B. Through what angle has wheel between? How much the angle between them? It will move. The wheel. We are talking about the wheel. I will solve the previous example for you in detail by another video. But let us now finish this one. Okay, we need delta theta from t equals 0 to t equals 2.5. Yes, 2.5. Delta theta is equal to omega naught, because this is theta minus delta 0. This one. It is omega naught multiplied by t plus half alpha t squared. Now, omega naught is this relation. It's omega naught. T is 2.5. 2.5, and this is 2.5 squared. Alpha 0.2. So delta theta will be equal to 2.5 omega naught plus this with this one. Actually, it will be 0.625. This is theta or delta theta. This is in radians. Now you have many examples. I will try to record solving many of them for you. We are done today, and I will upload them in the YouTube, and you can see it. Any questions and any issues? If you have any questions, please send them to me to solve them for you. And that's it today. Thank you.